Hello, welcome back to our discussions of ArrayList and comparator, which we've used, as we've seen, to generate a sort method. So now that we know about comparators, we can sort the ArrayList in any way that we wish by coding the compare_to method, right? So we have complete control of how the ArrayList is going to be sorted, and we can have, in different instances, the same ArrayList sorted in very many different ways. That's very useful because in different contexts, this is preparing a list for the user interface. You may want to have your objects sorted in various ways. So there's a lot of overhead here, though, right? We have to declare the class, implement the employee ID, and then instantiate it. And along the way, we've retaught the compiler lessons. That is, I promised to implement this interface. Well, then I do implement that interface. Well, as Java evolved, they've tried to eliminate duplicate work on the programmer part. And so one of the first ways that we're going to look at a couple of different ways that they've reduced the work. One really radical. This is the intermediate step that they move toward, and that is the anonymous class. So here, in creating the anonymous class, we do new comparator, right? There's no class but in here, it's using no class definition. The compiler knows how to write the class. We can't do new comparator, literally, because this is an abstract class. We can't create an object of its type. What this is an anonymous class. It's a class that has no name. When we say new comparator, that is new interface. This is a general lesson, new interface, right? We're declaring an anonymous class because we're using it on the fly. Here within this curly braces, then, we have to implement the methods of this interface, right? The compiler already knows the compiler already knows the shape of the class we need because we're implementing an interface, new comparator. So it knows that we have to write the compare method already. It doesn't need to retaught that method as we've done here, right? Again, this is evolutionary. So earlier versions of Java, you had to do it this way. As different versions of Java came out, they came out with the anonymous class to say, you don't have to do this redundant work. The compiler already knows it has to have a compare_to method. And again, it's not just comparator, it's any interface will work this way. New interface, and then within these curly braces, on the fly, you declare the methods that you've promised in that particular interface. In this case, the compare_to method. Notice, if I change the function signature here by changing its name, the compiler will now fuss at me for not implementing the methods of the comparator, same as before. Okay, so I'm just going to compare. Let's sort by skill here. So using the anonymous class here, where you're doing the compare method, we're going to do get skill, compare to O2 get skill. This is very similar to the coding of the compare method over here, right? Very similar. Let me restore my perspective. So the coding of the internal of the method is the same. We've just removed the redundant work. Redundant work meaning the compiler already knows what this class has to look like, so we don't need to compare it. We don't need to actually write one. We can use an anonymous class, meaning the compiler generates the class for us. Let's look at the next level. Let's take a look at the sort method here. Let's learn a little bit more about Eclipse 2. I'm going to hit the Control key, and then I click here. I can open the declarations of the sort method, and we can take a look at it from the standard library. Notice there's a comparator here. So it knows there's a comparator here, and the comparator is a special type of interface, functional interface. Notice. So what's a functional interface? A functional interface is an interface with one method, and that's important. What I'm about to show you would not work with an interface that had more than one method in it. Because again, we're teaching the compiler how to write our code for us, right? We're giving it kind of boilerplate. It's not doing anything intelligent. It's following the pattern we're giving it. So if you give it an interface with one method, it not only it knows how to create an anonymous class, but it doesn't even need the anonymous class anymore. It just needs the method. It will then build up the object, and the class remains anonymous. So this is essentially. So before we made the class disappear and become anonymous, the next thing we'll do is make the object creation disappear. And again, evolutionary step. This happened as Java evolved. Okay, now we're ready to go to the next level of what the compiler knows about. Since the interface is a functional interface, it requires only one method. The compiler knows the shape of the function we need to write. It knows the parameter types and the return type. Why does it know it? Because it's typed right here, comparator. So we know what the comparator requires. It requires a compare method that returns an integer. That compare method though doesn't even need a name. So here's our Lambda expression or arrow function here, right? From here to here is our Lambda expression. Right? Here's our parameter list. Where are the data types for the parameters? The compiler already knows them. We don't need to remind them. Right. Then you have an arrow, a single dash, and a greater than sign. And then we have a method body here. And then we return the method. So this is the most extreme case, and this is as far as the Java designers have pushed this, of having us write a method that fulfills the sort method. The compiler already knows all the details, and we're taking full advantage of that. So let's look at the evolution. We create a class that implements comparator. This is our first method, early Java. We create a class that implements comparator, and then we instantiate an object. We saw that. Right? That's the full up method. And then we say, well, we already know that we need to create a class that implements comparator. Therefore, we know we don't need to create a class. The compiler knows what it needs the function it needs to write, all the methods that the interface demands, right? So this says all the methods that the interface demands will be created in the following braces. There's no explicit class here. It's an anonymous class. Well, what else does the compiler know? If it's a functional interface, and only if it's a functional interface, the compiler also knows the function we need to write. And that's what we do here. So it doesn't need the class, it doesn't need an explicit class, it doesn't need an explicit object, it just needs to know what's the shape of the function we need to write. So here we have created this Lambda expression. It knows the compiler already knows the parameters types. Notice that it knows their employee, right? And all we have to do is write the method, right? We'll push this a little bit further in the next example. So in this next example, we push the arrow function a little bit further, and that is we remove its method body here and the return statement. The compiler already knows that it has to return. It knows the return type. So all we have to do is have a Java expression here that matches that return type. That is, what's the compiler going to provide? What's the compiler going to demand of us? That we have two parameters here. It already knows their types, so we don't type them again. And it also knows that we need to return an integer. So this expression, this simple expression here, its constraint is that it needs to evaluate to an integer. That's it. Notice there's no return here, no method body. So if you have a single liner, this is the fastest way to do it. You just say the parameter list here and the arrow, and then the single expression that returns the integer. If you have more than one thing to do, you'll need the body if there's elaborate logic. But in most cases, this is also called a callback method. They tend to be very simple. That is, we have a sort method that knows how to sort the array list very efficiently and very quickly. It's very sophisticated. It needs to know one piece of information. How do you view the sorting of this particular object? And that's up to the designer. And so here notice this is both comparing to skill. I'll put a negative in front of this, so it'll return, so it'll do reverse sort order on skill. So we see on the first sort order, we see embezzling first, then math, then speed, then weather forecasting, whereas when we put a negative in front of it, we have weather forecasting, speed, and math, and embezzling. Okay, so this is the arrow function, very valuable. You'll see this quite commonly in the use of the standard Java library. Thank you.